Right, okay, so let's have a look at question 7, a transformations question. We're aware about the fact that we've got transformation from the Z-plane to the W-plane is given by the given formula. So if we've got to show that the circle, so this circle in the Z-plane is mapped to a circle in the W-plane, and give the equation for it. So let's rearrange this first equation for Z. And then let's substitute it in our equation that Z satisfies being a circle. And that'll be it, pretty much. So, multiplying up. Okay, this is a type of equation where you have got to sort of multiply, factorize, rearrange, and so on. So, multiplying out, WZ plus IW is equal to 3IZ minus 2. Get all the Z's on the same side, so I've got 2 plus IW is equal to 3IZ minus WZ. Factorising out the right side, we've got Z times 3I minus W. So then that tells me that Z is equal to 2 plus IW over 3I minus W. And our equation for our circle, we've got Z plus I, so let's work out what Z plus I would be. So that'd be 2 plus IW over 3I minus W. It's going to be plus I. So to get the same denominator, I need to times everything this by I. So we're going to have 3I squared minus IW. So 3I squared is minus 3. So that's going to be minus 1. IW is going to cancel out with that one. So we've got 3I minus W. So then, in terms of the length of it, I can say that the length of Z plus 1 is, using a bit of a cheat, I guess, that's going to be 1 over the length of the modulus of this thing. And I know that the modulus of Z plus 1 is 1. So I've got 1 is equal to 1 over the modulus of 3I minus W. I can rearrange that and say 3I minus W is a 1. And of course, the modulus around that's written, so I can easily do that as well, because it's just times by minus 1 in the modulus, which ends up cancelling outside of it. So in terms of a circle, that's going to be, now, because it's W, so Z we tend to think of as X plus IY. W, just using different letters to make it clear, even though we've not used them in this question. So this is going to be U squared plus V minus 3 squared is equal to 1. So that's our equation for W. That's the equation that is going to be in the W plane. Okay, we now need to sketch C and D on argand diagrams. So let's sketch our original circle on the complex plane on the real and imaginary axis. So we've got the real axis, got the imaginary axis, and we've got a complex plane. So we're going to think about the Z plane. So I'm actually making a note saying it's the Z plane. Or you can follow convention, we're going to call that X, and that's going to be Y, not the real part of X. So it's the real axis. I'll just put X and Y. So we've got the Z plane. What was that? That was the circle given by that equation. So that's X squared plus Y plus 1 squared is equal to 1. That's squaring the whole thing. So that's centered at 0 minus 1, and its length is 1, so it's going to touch that axis. So center of it is at minus, so X is 0 minus 1, that's the center, and the radius is equal to 1. Now think about in the W plane. I think you'd think of a straight line lines, U and V. Now thinking about the W plane, and I like to make it clear it's a complex plane by just putting the complex set at the top. Then this circle, we've got X coordinates 0, Y coordinates plus 3, and the radius is 1. So we're going to have a circle, something like that. The centre is going to be 0, 3, and the radius is still 1. And that's it.